Hello, welcome to this video. In this video, we will learn the definition of specific heat and also the definition of specific heat at constant pressure and constant volume. By the definition, specific heat is the amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius or 1 Kelvin. So it is denoted by the symbol C. It is given by Q divided by M into delta T, where Q is heat required to raise the temperature, whereas mass is denoted by M and delta T could be temperature difference in degree Celsius or in Kelvin. So we can derive the unit of specific heat. So heat, if we substitute in kilojoule, mass in kg, and delta T could be substituted in degree Celsius or Kelvin. Now there is no difference whether you substitute the value in degree Celsius or Kelvin. For example, let us say, because we are talking about delta T here, whenever we talk about delta T, we are saying delta T in degree Celsius and delta T in Kelvin is same. So there is no need to convert. For example, if we take temperature like 30 degrees Celsius as T2 and temperature T1 as 20 degrees Celsius, if you substitute this same in Kelvin, 30 plus 273, 30 plus 273 is 303 degree Kelvin, and similarly T1, 20 plus 273 is 293 Kelvin. Now what is delta T in degree Celsius? It is 30 minus 20, 10 degree Celsius. Similarly, what is delta T in Kelvin? It is 303 minus 293, 10 Kelvin. So, technically speaking, these two values, whether you substitute kilojoule per kg degree Celsius or kilojoule per kg Kelvin, they both will be same. Now, let us understand specific heat. Let us consider a beach where sunlight is received by seashore and sea. We know that seashore has got sand, whereas on the other hand we have water. Now, remember, both sand as well as water receives same amount of heat from the sun. But we see that the sand gets heated up faster, whereas water gets heated up little slower. Even though the water and sand's quantities are different as of now, let us imagine even if you keep it at equal quantities, this is going to be true. So what happens? The sand heats up faster, seawater heats up slowly. Obviously, air over the land becomes hot and light, and because of which we see that this air above this sand gets heated up and start rising. So because of that, you see that there is a empty space because hot air rises up here and relatively cold air comes from the relatively colder surface, that is air above the water. So the breeze will be sea breeze, that is the direction of wind during the daytime will be from the sea towards the seashore. So that is why we have said hot air over land rises. So cool air from the sea move towards land. So what happens during the night is reverse, because during the night time, you know that the sand gets cooled faster and relatively water is warmer. So here the air rises up, and because of this empty space, the air above this sand, which is relatively cooler, take this space. So because of which you can see that there will be a land breeze, that is warm air over sea rises, and the direction of wind will be from seashore towards the sea. Now, we can argue that, okay, let us take the same example of daytime. We can argue that both sand as well as water is receiving the same amount of sunlight. Now, how do you think sand is getting heated up faster? The idea is that C, that is specific heat. C is the amount of heat required to rise 1 kg of a substance. So, let us take 1 kg of sand. If you want to increase the temperature of 1 kg of a sand by 1 degree Celsius, all you need is 0.8 kilojoule per kg degree Celsius. So, if you take 1 kg of sand and to rise 1 degree Celsius, you need only 0.8 kilojoules of heat, correct? Whereas if you go for specific heat of water, water needs 4.187 kilojoules of heat for rising 1 kg of water by 1 degree Celsius. Now we can see the difference. So that means if you keep water 1 kg and if you keep sand 1 kg, to rise each of them by 1 degree Celsius, sand needs just 0.8 kilojoule per kg degree Celsius, whereas water needs 4.187. So we can see the difference, which gets heated up faster, the one which has a lower specific heat. All right. Now let us take the CV and CP. Now CV is the amount of heat required to rise the temperature of 1 kg of a substance by 1 degree Celsius when the volume is kept constant. Now let us try to find out the specific heat of air. How do we find out? So we start heating up the air and we try to note down what is the amount of heat it takes to rise 1 degree Celsius. We have taken 1 kg of air and we are trying to heat it up and we are trying to find out the value of Q, and that determines what is the value of specific heat. Now if we do this by locking the piston, so the volume is held constant. So specific heat of air at constant volume. So volume is held constant. So it is the amount of heat required to rise the temperature of 1 kg of a substance by 1 degree Celsius when volume is kept constant. Then that is called as specific heat at constant volume CV. Specific heat at constant volume CV. Similarly, on the other hand, CP is the amount of heat required to rise the temperature by 1 degree Celsius when pressure is kept constant. So you are allowing the piston to move upward so that the pressure is not rising here. As soon as this pressure rises, so the piston start moving upward, so equalizing the pressure. So pressure remains constant in this example. So you are allowing the piston to move up and down. Whereas on the other example CV, we held the volume constant by locking the pistons. So CV of air is found to be 0.718 kilojoule per kg degree Celsius or kg Kelvin. So this is what we talked. You no need to convert here. Both will be same. Kilojoule per kg degree Celsius and kg Kelvin. They both are same. On the other hand, CP is 1.005 kilojoule per kg degree Celsius or 1.005 kilojoule per kg Kelvin. So this is for air. The value of CP is little higher than the value of CV. We can see that if we start heating this up in the second example, all the amount of heat which we are adding is not resulted in the temperature. There is some amount of energy is utilized in moving the piston. Because of that, it requires little more energy to rise the same 1 degree Celsius. On the other hand, CV, the piston is locked. All the amount of energy which we are talking here, the heat, so is resulting in rise in temperature. So the value of CV is lesser. The value of CV is lesser than value of CP. It is because of this reason, the amount of heat which we are giving at constant pressure is bit utilized to move the piston forward. So, in order to make the pressure constant, so Cp is little higher. We need more energy to do the same temperature rise. Now, when we come to solids, when we talk about solids, we do not talk about Cp and Cv separately. We talk only about specific heat C. It is because of simple reason, there is not much change in its volume when we heat. So, because of which there is not much difference between Cp and Cv value. So, it is only C. Thank you.